This video is Rational Expressions Part 2. We learned in Part 1 that the only way we can cancel binomials is if they are identical binomials. But there is a little twist that we need to cover in this video. So let's review a little bit here. X plus 2 over x plus 2. This binomial and this binomial are identical, and I get to cancel those out and just get 1. We're not canceling them individually. It's not x with x and 2 with 2. It is the binomial x plus 2 with the binomial x plus 2 gives us 1. You look here, it looks like they're not identical, but they are because x plus 4 and 4 plus x are the same. When you add expressions, the order doesn't matter. So these do cancel out and give us 1. X minus 5, x plus 5, they are not identical. Subtracting 5 from a number is not the same as adding 5 to that same number. So this expression right here cannot be simplified. That's as simple as it gets. You might keep that same reasoning and look here and say x minus 5, 5 minus x cannot be simplified. But there is a little trick that we can use to simplify this. So let's start out by looking at the order here. If I just switch this order on the bottom, I'm going to have negative x plus 5. When you have a negative lead coefficient, you want to factor that negative out. And when you divide this by negative 1, and you divide this by negative 1, which is what you're doing when you're factoring out a negative 1, it changes the signs. Negative x divided by negative 1 is positive x. 5 divided by negative 1 is negative 5. So now we do have identical binomials. X minus 5 cancel out. And when I cancel those out, of course, there's a 1 on top, and 1 divided by negative 1 is negative 1. That says this simplifies and gives us negative 1. This is going to be the setup anytime you have the same two terms on the top and the bottom, but in reverse order, and separated by a minus in both cases. I call these negative identicals, kind of a strange term, but it's the idea that they are almost identical, but because of this opposite order and the minus between them, we end up with a negative 1 rather than there being a positive 1. So anytime you have the same terms, x, a, they're the same terms, top and bottom, order is opposite and there's a minus between them, you may cancel them out and get a negative 1. So x minus 2, 2 minus x, perfect setup. I can cancel those out and I get negative 1. 5 minus x minus 5, perfect setup for the negative identical idea, we get negative 1. Just to review something right here, 3 plus x and x plus 3 are plain old regular identicals because the order doesn't matter when you add. So when you cancel these, you get a positive 1. But x minus 7 or x plus 7 will not simplify. There's nothing we can do with this. This is the best we can do with this expression. Now, another way to look at this, let me explain with some numbers. Pretend we put like a 5 in here for x, for both of these x's. 5 minus 2 is 3. 2 minus 5 is negative 3. 3 divided by negative 3 is negative 1. That's the reason it's going to give us this negative 1, because as you subtract in a reverse order, you get the same numbers top and bottom. It's just that you're going to have reverse signs. That'll happen no matter what value I pick for x in these. Check it out over here. Let's say x is 5 here. 5 minus 7 is negative 2. 5 plus 7 is 12. That does not simplify into negative 1. It may reduce to negative 1/6 coincidentally because of what numbers I chose, but it does not equal negative 1. This is the only kind of format that will cancel out and give us the negative 1. Now, with expressions, we're going to have to do the same thing we did in the previous video. You cannot cancel these until they are written as products. The only way to get them written as products is to factor them. The top factors as x minus 2 times x minus 3. The bottom, all we can do is take out a GCF. And when I do that, I'm left with 2 minus x. Just a reminder here, this depends on you being able to factor. If you're still weak on your factoring, you need to go back and look at the different factoring videos. You can, at any time, pause the video to practice the factoring on your own. Notice x minus 2, 2 minus x. And instead of canceling this out and leaving a negative 1 behind, all I do is cancel them out and put a negative out here in front of the line. That takes care of my negative 1 idea. And it gives me this answer, negative in front of the parentheses x minus 3 over 3x. That is equivalent to putting the negative in the top. Now, if you put the negative in the top, be sure you have parentheses around that binomial. We also could put the negative in the bottom. So a negative here is equivalent to having a negative in the top or having a negative in the bottom. Notice the negative here did not give us a negative in both places. So any of those three are acceptable answers. Let's look at another one. This kind of factoring right here, you might think about doing your tic-tac-toe. The bottom is the difference of two squares. So the top factors is x minus 4 times 2x plus 3. The bottom is the difference of two squares, 4 plus x, 4 minus x. Notice right here we have this negative identical situation. So I can cancel this, and leave a negative behind. I just put it even with the line. I could put it up at the top, I could put it in the bottom. I would just be sure you put it in the same place every time, and that way you won't get confused. So that will give us this answer right here. I did drop the parentheses on the bottom for no special reason. I do have the negative exactly even with the line, so I don't have to have the parentheses. If you are more comfortable leaving the parentheses there, then that's fine.